In this section, we're going to look at hypothesis tests that talk about means, and just like in the last chapter with the confidence intervals, you have the two cases. If you know sigma, the standard deviation for the entire population, then you use a z, and if you don't, then you use a t. So in this section, we're going to focus on the z's where you do know the sigma. Remember that when we're dealing with means, we do need our sample size to be larger than 30 for the calculations to work well. So we will need to check that as we go. In the flowchart, we'll be going down the left now with the mean and then checking whether the population is normal, or if it's not normal, is it sample size larger than 30, and so on. And in the calculator, instead of the z-interval, we'll be using a z-test, and it's the very first choice when you go into stat tests. Just like in the last chapter with the intervals, you have a data and a stats option. So if you have a list of data, you can enter that. Otherwise, you'll use the statistics, the mean and the standard deviation. This time we've got a mu0 to stand for the claim amount. We've got a sigma for the population standard deviation, x bar for the sample mean, n for the sample size, and then a line to put in the symbol from your alternative hypothesis. And again, after you calculate, it'll pop up with the screen with several pieces of information, and the one that you want to zero in on is the p. And then once you have your p-value, you'll compare it to the significance level, the alpha, and decide whether to reject or not. To do that process, we'll run through 5 steps just like we did in the last section. So we'll set up our hypotheses, get our p-value, make decisions about the null and the alternative, and then write up a nice final conclusion. So we'll take a look at a few examples. Let's say we're testing a machine that automatically dispenses coffee. It's supposed to be dispensing 6 ounces. We think it differs from that. Random sample of 40 cups. The mean for the sample of 40 was 6.2. We happen to know that the population standard deviation is 0.5, and we're going to use a 0.05 or a 5% significance level. So just kind of pulling out important information. That means our n is 40, our x bar is 6.2, and our sigma is 0.5. We are not told that this is a normal distribution, but the sample size is 40, so that's large enough to continue. So the steps are going to be the same as the last section. The screen will just look a little bit different when you enter the information. So first we're going to set up our hypotheses. Well, the hypothesis is, the claim is that the mean is different from 6. So that's going to be an alternative. That's the mu not equal to 6. We're using mu now because we're talking about means. That means the null will just be mu equals 6. It's always the same number and then just an equal sign. Okay, so we go to stat tests and we choose the very first one, z-test. We have the mean and the standard deviation, so we're going to pick the stats option at the top, put in that the claim is 6, the sigma is 0.5, the x bar is 6.2, and the n is 40 with an alternative of not equal. Go ahead and calculate. Screen pops up with some different information. What we're interested in is the p-value. So on these there's just one p, so find that. Round to 3 significant digits, so 0.0114. Alright, once you've got that, you need to find your significance level. So that's the alpha is the significance level, 0.05. So we've got a 5% cutoff here for unusual. Well, our 0.0114 is smaller than that, so we have an unusual result. We're going to reject it. So we're rejecting the null. That p-value always refers to the null. Reject the null. That means we support the alternative. That always goes together. If you reject one, you support the other. And we have enough evidence because this was smaller than 0.05. It was fairly conclusive. So we do have sufficient evidence to conclude that the mean amount dispensed from all coffee cups in this machine would differ from 6 ounces. This next example gives us 2 standard deviations. Remember that if you have both the population and the sample, the population is the preferable one. So funding will not be provided for a new remedial math program unless at a 0.01 level of significance, so that's our alpha, it can be shown that the new program will make average scores exceed 82. We've got a sample of 50 students. mean of 85, standard deviation of 7. We know that the population standard deviation is 5, so that's actually the one we want. So we want to test that the mean score for all remedial students would actually exceed 82 like we want it. So pulling out the information, n is 50, that was the sample size. We had an x-bar of 85 and a standard deviation. Well, the sample standard deviation was 7, but the population standard deviation was 5. So we'll actually use the sigma for this. Go through your 5 steps. So the claim is we want to show that this mean score exceeds 82. So our claim is the alternative, mu greater than 82, which makes the null equal to 82. Go to stat test, do your z-test, put the information in with the sigma of 5. Do not use the standard deviation of 7. And your p-value to 3 significant digits has a bunch of zeros on the front and then 1, 1, 1. Well, that's very, very small, so most significance levels would reject that, but find your significance level. Our significance level is 1%, 0.01, definitely smaller than that. So we're going to reject the null as too unusual. That means we're going to support the alternative, which was our claim. So we do have sufficient evidence to conclude that the mean scores on all standardized exams for these students would exceed 82. Alright, so I'm going to have you try this one on your own. Perfume distributor believes that the mean cost is 13.25. Someone within the company argues that it's less than that. Random sample of 50 orders. We have a mean and a standard deviation. We are told that the processing costs are not normally distributed, but they are known to have a standard deviation of 60 cents. They're not normally distributed, but the sample size is over 30, so we are safe on this one. So the claim is that the cost is actually less than 13.25. So pause, try this one, and then I'll give you the answer. Alright, so the claim was that it was less than 13.25, so mean less than 13.25 is the alternative. That makes the null equal to 13.25. Stat test, do your z-test. We're putting in a sigma of 0.60. Remember, when you have the one for the population, that's what you want. Okay, the 62 cents was in the sample. X bar is 1310, and we have an n of 50, so get all of that in there. Your p-value is 0.0385. It would depend what your cutoff was here. We're supposed to have a level of significance of 0.01, and 3.85% is more than 1%. So this is a case where we fail to reject. That's not small enough to reject. So we fail to reject the null, which means we fail to support the alternative. When the word fails in there, that means you do not have sufficient evidence to conclude that the mean for all of the orders would be less than 13.25. Now I'll have you try one where the claim is equal. Sociologist wishes to discover whether the mean number of people per family in an apartment complex is equal to 4.80. Interviews 100 people, mean of 4.60, standard deviation for the whole complex, so that's population. Sometimes it doesn't always say population, but sometimes there are words that indicate it, like all or whole. So we have a population standard deviation of 0.80. So go ahead and try that one. Okay, let's see how you did. So claim is the equal this time. So the claim is actually in the null, which means we're going to have to be very careful when we phrase our conclusion. When the claim is equal, then the alternative is just a not equal to be the opposite. Z-test with an X bar of 4.60, a sigma of 0.80, n of 100, comes out to 0.0124. Our cutoff this time was 5%, 0.05 significance level, so we are smaller than that. This is small enough to reject the null. So we're rejecting the null, which means we will support the alternative, but the claim this time was the null, so we need to be very careful how we phrase this. We don't have the word fail in here anywhere, so there is sufficient evidence, but the claim is the null, which is the one we're rejecting. So we have sufficient evidence to reject the claim that the mean is 4.80.